Okay, so if you understand that, then we can move on to a very, very, very important idea. Very important idea, and it's misunderstood. I can tell you that now confidently that it is misunderstood by many people. And I need to create a distinction here, right? I need to create a distinction here. You see here, I said the product of what two numbers will give you 4. So the product of 2 and 2 will give you 4, isn't it? But the product of -2 and -2 will also give you 4. Think about that. If I said the square root of 16, then the product of 4 and 4 will give you 16, but the product of -4 and -4 will also give you 16. So before I actually elaborate on this idea, let me create the distinction now so you'll understand what I'm saying. Let me create this distinction because you need to understand this. This is the way we look at it. This is the way we do it. This is the way we do it, right? There's two cases. And this is only applicable when you're given the square root. When you're given the cube root, you don't have to worry. Because 2 times 2 times 2 can only give you 8. You can't say -2 times -2 times -2 because that'll give you -8. So it's only when you're given the square root. And this is what you need to remember. When you are given the square root and when you are using the square root, create this distinction. And I want you to write it in two different halves of the page. When you are given the square root, you will see it on your page. You will see it there. However, when you're using the square root, means you have to utilize it, means you writing it down. You are writing it down, means you're trying to solve for a question. That's why you will use a square root. When you're given it, it's more for simplification purposes, because you will see it in the question. Simplify. But when you're using it to solve a problem. Think about that. When you're given it to simplify your question. When you're using it to solve a problem. It's a tool. You're using the tool. When you're given it, there's one of two things that you could be given. You could be given a positive square root, right? A positive square root, or you could be given a negative square root. So on your page, if you see the square root of 4, the answer is 2. On your page, if you see the square root of -4, the answer is -2, right? However, when you are using it, for example, if I gave you the question, x squared is equal to 16, and I need to solve for x, the only way I can solve for x is by taking the square root of both sides. And if I take the square root of both sides, because I am using the square root, I must put a plus and minus sign there. So therefore, x is equal to plus or minus 4. Again, why we do this is because I'm saying, they're asking me, right? So yeah, they gave it to you. They're giving you the question. The examiner is giving you the question. You cannot change the question. You can only re-express it. However, when you're using the square root, and when you're solving a problem, you need to state every possibility that could make that statement true. Remember, this is an equation. You need to state every possibility that could make this mathematical statement or this equation true. And there's two instances whenever you're using the square root. You could have a positive instance where you'll have 4 times 4, that'll give you 16. And you could have the negative instance where -4 times -4 will also give you 16. Why? Because the product of a even number of negatives will be positive. And because this number here is a positive, because that number there is a positive, then we can confidently conclude that there are two possibilities. Do you understand that? This is what we mean by given and by using. Now, I know when I explained this here, I said that there could be two possibilities. However, in this case, this answer is correct. It can only be positive 2. And in this case, this answer here can only be positive 4 because you are given the square root. But I had to elaborate on this idea because I have to show you that there are two possibilities only when you are using the square root. Okay? And I hope you understand. I hope I'm driving this point home. Right? Okay. Given the square root, there could be a positive and negative. Using the square root, they can be both. Though I have to be both positive and negative. So here, it could be one solution when you're given the square root. It's either positive or negative. When you're using the square root, there's always two solutions. Always two solutions. And then sometimes, but I will not get into that, that's more complicated. Sometimes you have to reject one of the solutions, but I will explain that when we get to those parts. But when you're using the square root, there's always two solutions. Now, if you look at the cube root example, again, you also get positive cube roots. So that's square root, right? At cube roots, you also get positive cube roots, negative cube roots. But they don't have much significance because you're reading it as it is. You can get a positive cube root, you could get a negative cube root. But the positive cube root of 8 will be 2. And the negative cube root of 8 will be negative 2. There's not much that you actually need to think about. But you're just applying yourself logically. You're just applying yourself logically. That's all you're doing, right? Right. But if you're using the cube root, again, if you're using the cube root, so let's say that we have x cubed is equal to the cube root of 8. Or is equal to 8. And let's say that we have x cubed is equal to minus 8. Right? Then if you take the cube root of both sides, in this instance here you get x is equal to 2. And in this instance here you get x is equal to minus 2. Nothing fancy. Utilizing the cube root, given the cube root, you could either be given a positive or a negative cube root. Utilizing the cube root, there will also only be one solution according to what you're given. And again, you always need to ask yourself this question. Always. When you're using the cube root, you need to ask yourself, so the product of 2, 3 times. So the product of 2 times 2 times 2, will it give you 8? Yes, it does. The product of minus 2 times minus 2 times minus 2, will it give you minus 8? Yes, it does. And that's the reason why I actually elaborate on the idea of exactly what a cube root means and exactly what a square root means. Because when I came here, and if you ask yourself the question correctly, is the product of 4 and 4 16? Yes, it is. Is the product of minus 4 and minus 4 16? Yes, it is. That's the reason why you have two solutions. So if you're starting to think outside the box and you're utilizing your definitions, then you will be able to solve these questions correctly. Because if you went, then you're definitely not answering these questions correctly. Right? So again, let me just give you an overview now. When you're given the square root or given the cube root, there can only be one solution, and that solution will be dependent on what you're given. Are you given a positive or a negative? Square root or cube root. When you're using the square root, there will always be two solutions, and sometimes we reject one solution. And when you're using a cube root, there will only always be one solution. Okay? I promise you, for now, consider these as rules. Consider these as rules. If you have read my principles of studying, my universal study principles, one of the things that I state is that never question rules. You need to know exactly when to question rules and when not to question rules. Because rules were created so that we can follow them. And they were already questioned by great minds. For now, I am telling you to consider this as a rule. Do not question it. Next year, I will give you a thorough understanding of what and why this is the case. But I will give you the more graphical approach. But at this point here, I cannot teach you that because we have not covered functions yet. But I promise you, when we cover functions, it's literally, I think at the point of functions, it's when everything will piece together. I promise you. If you have to name me one section that's the most important section in maths, it's functions. And I will always say that. Right? Every topic of maths is like the parts of the car. Without one, the car will not move. However, if I had to deem one of the sections superior, it will be functions. Because that's when you get a proper overview of maths and what maths entails. Okay? So that's basically this first part here. We have to actually elaborate on these ideas given and using the square root. So let's do a few examples so that I can ensure that you understand the problem, right? Let's say we were given minus the square root of 81. Number 1. Number 2. Let's say we were given minus the cube root of minus 27. Let's say we were given x cubed is equal to 64. Number 4. X squared equal to 18 minus the square root of 4. Let's say we have like something like the square root of 49. Say we have square root of 49 plus 2 minus the square root of 4. Right? So let's say we have these examples here. If you have to solve these questions, the first thing that you need, or the first thing that needs to come to mind, is that whenever you see the square root, you need to stop and think. Because if you're given the cube root, it's straightforward. But when you're given the square root, you need to stop and think. This is how you're going to think about it. So square root, stop. Right, square root, stop. Ask yourself two questions. Is it given or do I need to utilize it? So that's what we're going to do here. In the first case, is it given or do we need to utilize it? What's the indication that it's given? You will see it on the page. That's how you know it's there. So if you look at the first one, we are given the square root. If you're given the square root, there'll only be one solution. That solution will be dependent on whether we are given the positive square root or we are given the negative square root. If you're utilizing the square root, there will always be two solutions. Right? There'll always be two solutions. There'll be a positive and a negative. So when we are using it, we must include the positive and negative sign. In the first case, we are given the square root because I can see it on the page. And we're given what square root? We are given the negative square root. So this answer here will be -9. If you look at the second example, that's a cube root. Very straightforward. The cube root of -27 is -8. Why? Because, remember if we follow BODMAS here, right? You have to first do the radical sign because we treat the radical sign or the root sign, the cube root, as a grouping symbol, as a bracket. So we have to solve that first, then solve everything else, then come to the multiplication. So far we'll have -1 times, and we'll say the cube root of -27 is the same as asking the product of what three numbers will give me -27. And it happens to be -8. And if you have to simplify this, minus times a minus is a plus, 1 times 8 is 8. If we look at this example here, very straightforward. I have to take the cube root of both sides. So cube root here and the cube root here. Then I'm going to ask myself, the product of what three numbers will give me 64? And it can only be 4, not -4. So it can only be 4 and not -4. If we look at this example here, let me elaborate here. Right, the square root of 4. If I have to simplify this, 18 minus the square root of 4, we're given the negative square root. You can see it. So this is a miscellaneous question where I gave you a combination of given and using. So in the first case, we are given the square root. If I have to, this is where we're given it because you can see it. Here you can't see it. So therefore, it'll be 18 minus 2, which is 6. Right? And now I am using it. I am writing it down. So when I'm using it, I must put the plus or minus sign. And therefore, x is equal to plus or minus 4. Is this correct? Yes, the product of 4 and 4 will give you 16. And the product of -4 and -4 will also give you 16. See, the product of what two numbers will give you the number under the square root. Okay, very straightforward. But here, like I said, here we were given. And in this step here, we used. So that's how we can start mixing it up. But if you're smart enough, if you've got a good eyesight, you'll be able to see it quick. The square root of 49, I can see it on the page. So it's given. There can only be one solution. That solution is dependent on whether you're given the positive or the negative square root. Here I'm given the positive square root, so the answer has to be positive. So the product of what two numbers will give you 49? 7. But it'll be positive 7 because it's the positive square root. If you look at this example here, I'm given the square root. So, and I'm given a positive and a negative square root. So positive square root of 49 is 7 plus 2. Negative square root of 4 is -2. Because the square root of 4 is 2, right? The product of what two numbers will give you 4? It's only 2. Right? Because you are given the square root, but it'll be -2 because it's the negative square root. And this answer here will work down to 7. Right? Very, very straightforward. It's not difficult. You're given the square root, check whether it's positive or negative. If you're using the square root, there will always be two solutions. So do not forget to add the plus or the minus sign. Right? Very, very straightforward ideas. I hope I elaborated on this enough. Sometimes what we could have the case where, and this is where we're going to start linking sections, right? So under exponents, let's say we had a question 8 and it said the square root of -9. The answer to this question is that it'll be a non-real number, correct? It'll be a non-real number. So therefore what we say is that there's no real solution. There's no real solution. You could get another number like the square root of -50. You could get the square root of -50. Here as well, you'll say no real solution. Right? That's how you write the answer because it's a non-real number. No real solution means that it cannot output a real number. Right? That's the reason why. Do not take it in the literal sense. Take it from the mathematical standpoint, where we're saying that it cannot output a real number. Therefore, it's no real solution. At university, you will be able to plot non-real numbers, right? You will be able to plot non-real numbers on the complex plane, right? That's why we call it the complex number system. So on the complex plane, you will be able to plot the real numbers. However, on the Cartesian plane, you can only plot real numbers, right? So like your rational, irrational, and so on. But on your complex plane, you'll be able to plot non-real numbers. However, as I said, with undefined numbers, they do not exist at all, right? With undefined numbers, they do not exist at all, right? So that's basically it, and basically a good overview of some of the questions that you could get. Right? These questions here that you see a no real solution, they could be in other questions. So as we start elaborating on solving equations, and you're given more practical examples like word problems and so on, and as we get to calculus, you will see that you see this idea here where you have x squared and where you have two solutions. Sometimes one of those two solutions won't work. But for now, all you have to remember is that when you're given the square root of a negative number, the answer is no real solution, right? However, I can stretch this, I can expand your mind more by saying that the eventh root, so the fourth root of a negative number, is also no real solution, right? I think I would have mentioned this. So it could be the square root of a negative number, or more generally, it could be the eventh root. So the fourth root, the sixth root, the eighth root, right, will always output a non-real number. Okay. Right, and in the next part of the video, we will discuss comparing exponents. Very simple idea. And then we'll go to exponential rules. Okay.